Today I received a video submission from one of my clients. I'm excited to see what she has to ask.
Hi, my name is Dominique Ward, and I'm a member of the FAU Women's Track and Field Team. I'm submitting this video submission to you because for as long as I can remember, I've always wondered why my legs have an excruciating burning feeling when I'm participating in a 400-meter dash race. I have chosen to come to you about this question because I know that you are in grad school studying exercise physiology and will be able to give me an explanation.
First off, nice to meet you, Dominique, and I hope that your season is going well so far. I appreciate that you have chosen to come to me about your inquiry regarding your sport. Essentially, the question that you have asked is, why do your legs burn while you're sprinting? Okay, I will answer this question through a series of information so that you can walk away with an in-depth understanding of what is going on in your body while you're sprinting. I understand that you're a 400-meter runner, which in track and field is an all-out sprint covering a full lap on the track. Most collegiate runners take anywhere between 51 and 60 seconds to complete a 400-meter race, depending on the level of training. This amount of physical stress placed on the body can cause various physiological responses, mainly in the lower body because this is where the muscles used for running are located. Essentially, in a study that took place in 2001, Nielsen and colleagues explained that during strenuous exercise, lactate acid accumulates, which produces a reduction in muscle pH. In addition, exercise causes a loss of muscle potassium, leading to an increased concentration of extracellular potassium ions. I know that there must be a million things going on through your head right now, so I will begin to clear things up. First and foremost, the burning feeling that you are referring to when you are sprinting is due to an accumulation of lactic acid. Carnes' study in 2006 defines lactic acid as an acid that is produced in muscle cells when the body breaks down carbohydrates to use for energy during times of low oxygen levels. Essentially, an excessive lactic acid accumulation is tied to the local muscular fatigue that you feel in your legs when you are well into your race. To help you better understand the role that lactic acid plays in the burning sensation you feel in your lower body while sprinting, I will present to you a closer look into what exactly is going on inside your body while you're sprinting. Bodies perform strenuous exercise, we begin to breathe faster as we attempt to shuttle more oxygen to our working muscles. The body prefers to generate most of its energy using aerobic methods, meaning with oxygen. Some circumstances, however, require energy production faster than our bodies can sufficiently deliver oxygen. In those cases, the working muscles generate energy anaerobically. This energy comes from glucose through a process called glycolysis. In this process, glucose is broken down into a substance called pyruvate through a series of steps. When the body has plenty of oxygen, pyruvate is shuttled to an aerobic pathway to be further broken down for more energy. But when oxygen is limited, the body temporarily converts pyruvate into a substance called lactate, which is often used interchangeably with the term called lactic. Lactate allows glucose breakdown and energy production to continue. The working muscles can continue this type of anaerobic energy production at high rates for 1 to 3 minutes, during which time lactate accumulation can become high. A side effect of high lactate levels is an increase in the acidity of muscle cells, along with disruptions of other metabolites. The same metabolic pathways that permit the breakdown of glucose to energy perform poorly in this acidic environment. On the surface, it seems counterproductive that a working muscle would produce something that would slow its capacity for more work. In reality, this is a natural defense mechanism for the body. It prevents permanent damage during extreme exertion by slowing the key systems needed to maintain muscle contraction. Contrary to popular opinion, lactate buildup is not responsible for the muscle soreness felt in the days following strenuous exercise. Rather, the production of lactate and other metabolites during extreme exertion results in the burning sensation often felt in active muscles, though which exact metabolites are involved remains unclear. This often painful sensation also gets us to stop overworking the body, thus forcing a recovery period in which the body clears the lactate and other metabolites. Nielsen and colleagues found in a 2001 study that accumulation of lactic acid actually protects against muscle fatigue. Their study involved the incubation of insulated calf muscles on dead rats to be used to evoke electrical stimulation of the muscle through lactic acid injection. In contrast to the often suggested role for lactic acid accumulation as a cause of muscle fatigue, the results of this study showed that in muscles where force was depressed by high potassium ions, acidification by lactic acid produced a pronounced recovery of force. Since intense exercise is associated with increased potassium ions, this indicates that acidosis may protect against fatigue, rather than be a reason to cause fatigue. Once the body slows down, oxygen becomes available and lactate reverts back to pyruvate, allowing continued anaerobic metabolism and energy for the body's recovery from the strenuous event. I hope it is now clear to you that the burning feeling that you are experiencing while sprinting is due to the buildup of lactic acid. Although the burning sensation associated with this accumulation can be painful, it is not harmful to the body. Overall, it should not be taken as a fact that lactic acid is a deviant that impairs exercise performance. The information that I have presented from the Nielsen et al. Study in 2001 on isolated muscles suggests that acidosis has little detrimental effects and can even improve muscular performance during high-intensity exercise. This is supported by the recovery of muscle excitability in the detached calf muscles of rats. Like most studies, there are limitations that must be recognized, especially for studies that follow treadmill and bike tests. Preferred measures of peak lactate values come from long-duration continuous activity protocols rather than short incremental protocols. And unfortunately, many tests out there focus on the shorter protocols because they're quicker, easier, cheaper, and it's more appealing. Ultimately, there are not many studies on lactate accumulation that involves outdoor strenuous activity, like running track, in the hot sun at that. Instead, many of the research studies regarding lactate accumulation occur indoors. I hope this video has given you a better idea of what is going on while you are running your 400-meter race. If there's anything that you take from this video, I hope that you understand that the pain linked to lactic acid accumulation is not your body trying to work against you. Fatigue is inevitable. However, I'm pretty sure that you'd rather feel fatigued at the 300-meter point of your race rather than at the 200-meter point. A study conducted by Curion and colleagues in 1988 examined the effects of mixed dieting, carbohydrate-rich dieting, and fat-rich dieting on the onset of blood lactate accumulation. The participants performed bike tests, and lactate values were obtained using blood samples. The results of this study showed that peak lactate values, workload, and performance time were not significantly altered by the imposed diets. With this being said, I encourage you to continue training hard on the track and engage in regular resistance exercise, because the stronger your muscles are, the more distances you'll be able to cover on the track before fatigue sets in. Thank you for your question and good luck on your season this year. Go Owls!